is SciShow Tangents, the lightly competitive science knowledge showcase. I'm your host, Hank Green, and joining me this week, as always, is science expert Sari Riley.
Yeehaw.
And our resident everyman, Sam Schultz.
Hi. I wasn't prepared to do a fun one.
So I wanted to ask you two a question. When you go to the dentist, do you get taken to a special room for people whose teeth are too big, or or not? Which of those two things is it?
You know we do, because we talked about it already.
Both of you do.
Yeah.
Both of you go to the special big teeth person room.
Okay,
you
don't go?
Existed.
How do you get your x-ray? When they x-ray your teeth, what happens to you?
I'm just sitting there, and they put a little thing in. They put a little thing, and then a gun comes down, and it shoots the side of my face.
They swing the gun down, like that.
Mm-hmm.
I got to go in a different room. I got to stand by a tower. They lower something over my head, and I bend forward and bite something, and it goes. Rrr, rrr,
yeah.
rrr. And I learned apparently
Sari has this too.
Right before this podcast started that means I have gigantor teeth, and no one's ever told me.
Yeah, because I recently went to the dentist, and they went to go do the laser one, as Hank described. And as they were putting it in my mouth, I was like, my teeth are too big for this. You'll see. And they were like, ha, ha, ha. What is this person doing? They probably get a lot of really obnoxious people in the chair saying this, but they put it in my mouth, and then they took a picture, and they were like,
that happens all the time. You think that X-ray gun can handle these teeth?
Yeah.
My
teeth are the alpha teeth. Yeah.
Wow.
Harassing the dental assistant. But I was like, I've been told before my teeth are too big. And they took a picture, and they were like, you're right. Your roots go right off the screen. Your teeth are huge. And then he was like, let me prepare the special machine for you.
I'll bring you over to the special room.
No one ever told me it was
for big teeth.
Yeah, I didn't know it was a special room.
Boys.
Me and Sari both have. If you've never watched us on YouTube, youtube.com/SciShow Tangents, you won't know that me and Sari have giant teeth.
I had never thought to myself that y'all have big teeth. Now that I'm looking at them,
we had a comment.
They don't seem tiny or anything.
There was a comment on one of the episodes that said, that guy sure has all the teeth, doesn't he? In reference to me. Rude.
They didn't even notice my teeth. They were too busy looking at yours.
And my big ones.
That happens. That guy sure has all the teeth. Well, before we can't go any further down this road. It is delightful to me that Sam didn't realize that it was a special room. He thought this happened to everybody.
I don't know why they didn't think I could handle knowing that. They just looked at me and said, he's too sensitive.
It's just too much.
Yeah.
Yeah.
Yeah, you're
like such a sensitive man.
But now you can feel included because we're in the majority here.
I love going to stand
Hank.
at the big room. I hate when they put the little things in your mouth. You have to like bite down. They're so sharp. I like just going in and have the thing go
One little
all the way
nibble.
around my head. Yeah.
Good for you. I'm happy for you both. So every week on SciShow Tangents, we get together to try to one-up, amaze, and delight each other with science facts while also trying to stay on topic. But the topic of the day is not teeth or big teeth, so we've already failed. Our panelists are playing for glory and for Hank Bucks, which I will be awarding as we play. And at the end of the episode, we will have a winner. We will also, at the end of this episode, have the winner for the season, because this is the last episode of this season of SciShow Tangents, according to this show flow, which I found out just now. But as always, first, we have to introduce this week's topic with the traditional science poem. This week, it's from me. Life is both simple and quite complicated, but its reason for being can be easily stated. You have packed inside you a whole lot of genes that determine together a great many things. The size and quantity of fingers and toes, how you get smells to your brain from your nose. A successful gene proliferates, and they only do that when you procreate. A gene can't live forever in a single creation. It wants to get passed to the next generation, so they keep you alive. For a while, at least. But each year, the challenge of that is increased. For the briefest of moments, life will rage, but from the moment it's born, it begins to age. Some species are great at breeding quite quick, so a very short life still does the trick, and the systems aren't there to keep them breathing because the genes have lived on through breeding. But if your body is big and you breed real slow, the pressure to stay alive longer will grow. But always, a balance is found from breath to breath. We are each of us one step closer to death.
Wow. A great
that was
end
really
of the
beautiful.
Season poem. That was beautiful.
Yeah, that's like an illuminated manuscript type poem.
I would love for my manuscript to get illuminated.
That would be the
Sounds
best
like
kind.
a great honor.
It's the best kind to have.
This is the topic of the day is aging, which is the thing that happens from the moment you get born, I guess, or maybe even before that. I don't know. Sarah, what's aging?
Yeah, I don't know. The thing is, it happens to us all. And we know that, and we observed that. And then we tried to define it biologically. And we were like, oh, man, that's complicated now.
There's a lot of stuff going on. If there wasn't so much stuff going on, it might be easier to deal with. But it turns out it's a lot of different things.
Yeah, it's a lot of different things all at once. So it does have to do with the march of time. So it is time-related aging. And in general, we think of it as the deterioration of any sort of biological, physiological functions. And they can be for survival, they can be for reproduction, they can just be general physical attributes, like a phenotypic changes. But generally, it's this idea that you captured so poetically that we just, over time, we break down. Entropy wins. And we slowly, the order in our bodies become less ordered. And we turn back into goo.
I mean, that's the last step.
Yeah.
The weird thing is that like we continue to live as we deteriorate, which is not a great frame to think of it inside of. Don't think of it that way. That's kind of what's happening, but not like who you are. You're you. And
is there like
whatever body you're in, love it, etc.
Is there like a part of you could point to that's the part that's getting older, that's making all the rest of it be less? Is it like your DNA? Is that the ultimate thing that's messed up? Or
it's not entirely clear. There are things you can point to that definitely have an effect, but there is not one thing that you can point to.
Yeah, and I think it's because you are so many things, which is also kind of a weird thing to think about. Like not only are you breaking down constantly, but you are also a collection of so many different molecules that you're constantly introducing to yourself and not in control of. So we think there are some genetic components to aging. In all the scientific literature, you'll see the word senescence instead.
Right.
And that's like the scientific term for biological aging. And so there might be genetic components, so like the way that DNA is arranged or stable or breaking down or replicating. There might be diet-related things, so like what food you eat or what environment you live in and molecules you breathe in and have around you. There could be stress components, like in the way that stress can affect your physical health, your mental health. It can also affect the rate at which you age. So like the whole gray hair caused when you're stressed, because stress and psychological damage can cause physical or phenotypic effects on our bodies as well. So all these things together become aging, and we have to tease out which pieces are which. And I'm not very good at that because being a human or being any animal is complicated.
So if a particular gene in a particular cell is designed to do a particular thing, it's going to do that thing ideally kind of perfectly the moment you're born. And then it's just going to it's not going to get worse in any particular way. It's just going to get less good at being that specific. It's going to be like less precise. And it's a bunch of imprecisions that add up to your skin not being as flexible and your body being less good at clearing stuff from your blood, or your things being more inflamed, etc. But then there's also absolute normal genetic things where it's like you're supposed to have these things, like graying hair in a gorilla might be to signal that I am a more advanced member in age, and so that you can see that phenotypically in the same way that we have sort of adult characteristics generally,
like your achy knee. So you don't hear kids go around saying, my knee. But you hear all those old fogies like us walking around.
So distinguished. His knee hurts. He's the leader of us all.
But it's good too. It's like also like you start as a baby and you don't even have everything fully grown. So they get a little looser,
true.
But they also get a little bit better.
It would suck to be a baby forever.
Yeah. So you don't want to be a baby forever. You don't want to be a teenager forever, definitely. Like that would suck even more than being a baby forever.
If I could have paused 4 years ago, I think that would have been just about right for me.
Yeah. Yeah, I guess I've sort of been thinking about just the senescence portion of aging, but just going from a baby to a teenager is also aging.
Yeah.
It's the whole process. There's so many different things that are aging. This is wild. All right, we can't talk about it forever though. So do we know anything about this etymologically?
Yeah. So age has just been a word. It's been a noun and then a verb for a very long time, and it has generally meant the same thing throughout history of like a time period, a long period, a lifespan, a lifetime, and then from that noun came the verb of you exist throughout time. And it comes from the Proto-Indo-European root AIW. I'm not sure how you say that. Which is vital force, life, or eternity.
Oh, wow.
But then senescent, I wanted to look into that because it's just such a nice word and it's such a weird word. That comes from the Latin senescentum, from the root word sen, which means old. And that you can see in things like senior or sir or senile or all kinds of like grumpy old people, surly.
Interesting.
But also in Senate, which I thought was funny. Like it's a council of elders. And so it's
stroking
got that
their big beards.
Senescence.
Yeah.
Senate.
More
Yeah,
now
everyone's
than ever.
rubbing their bald heads.
Yeah,
Stroking
bald
their
heads,
bald
achy
beards.
knees, telling people what to do.
Yeah, it does kind of suck that old people can just keep getting older, but we never invent any young people, you know? There's always going to be more older people. That's not good.
Yeah. Now there's all these people getting 114 years old, but we don't have any negative 2-year-olds.
Exactly.
What the heck? That's uncool. Now it's time to move on to the quiz portion of our show. We're going to be playing a version of Truth or Fail today, an aging Truth or Fail, because getting older is, of course, a gift, but aging comes with strange changes in physiology and behavior across the animal kingdom, some of which might seem particularly relatable to us humans. So the following are 3 stories of animal aging, but only one of these is true. Which one is it?
Can I add something real quick?
Yes, my dear.
That we are, that we are tied. Sari and I are tied neck and neck for the winner of this portion of the show. So whoever wins this part will have won the most of this particular part of the show for the whole year.
That's all right. I can't influence the outcome here. We'll just have to see what happens. Because I think this is Sam's only chance to win anything.
Yeah. No. I wasn't sure. Well, we'll see at the end, won't we, Hank?
We'll see at the end, won't we, Sam?
We crunch some numbers.
So it might be story number 1. The small, shaggy Brandt's bat loves to eat insects and moths. And as they get older, the bat shifts its meal times earlier so they can return to caves and sleep earlier as well.
Hell yeah.
So they get that, what's that called? The early bird
special. They might be literally eating birds. I don't know.
Or it could be the second story. As prairie dogs get older, they develop a bit of a crafting habit. They gather rocks from their surroundings and use them to build structures in their burrows that appear to make their homes a bit cozier, at least to us humans. We don't necessarily know what they're doing, but they look cozier to us. So maybe they're crafting as they get older. But it could also be story number 3. Scientists monitoring a community of macaques found that as female macaques got older, they got more exclusive about who they hung out with, restricting their social circle to just those they were closest with as they aged. So, is it our story of an aging Brandt's bat eating the early bat special so they can get to sleep earlier, the story of the older prairie dogs spending their times doing crafts, or story number 3, older female macaques become pickier about their social circles?
These are so good.
Because your icon was a bat for so long, Sam, I think it still is on Twitter. I think you know things about bats. Does it matter when bats eat?
That's kind of what I was going to say. I don't know anything about bats, really. I just think they're cool. But I feel like there's like a very specific window that's based entirely on when the thing that they're trying to eat is out. So it doesn't seem like it would work for them to go out earlier, to me at least.
Yeah. You got to go to Denny's while it's open. You got to go to the bug buffet while it's open. You can't.
The bugs are there. Yeah, exactly.
Yeah. Sam over here not knowing anything about bats, but still knowing things about bats. That's like a thing.
These are
That
vibes
counts, my
about
boy.
These are vibes about bats. I don't know if they're true.
The secret is Hank and I just operate entirely on vibes too.
Yeah, science is all vibes. I mean, it is all wiggles. We've been there.
And balls.
Literally
Wiggles
just
and
vibrations.
balls. The prairie dog thing, that seems so frivolous for a prairie dog. They seem like they have too much going on to be worried about that. They got black-footed ferrets to worry about, birds. They got to be on their toes.
A lot about prairie dogs.
I work on SciShow Kids, where we've done a lot about prairie dogs.
I think it could be a status symbol, though, of like, look how long I've lived that I have so many rocks. That's like an old person thing. Like, look at my tchotchke collection. I'm so proud that I have gathered this junk that is now all meaningful to me.
Yeah, it's going to be a huge problem when I'm not here anymore to deal with this.
I would love that one to be true because it's so cute. That's kind of the one I'm rooting for, but I just don't think they do it.
What about the macaques? Becoming picky.
This one seems the most practical of all animals. Of all the other things, this one seems like the thing that just like a natural decision. Be like, that guy's too annoying. That guy is always late to everything. That guy, he said something mean about me 15 years ago, and I just can't handle that anymore. That kind
Even
of
if you're a monkey, you remember.
Even, especially if you're a monkey, Sari. What do you think? You know the answer. You're tricking me somehow, I feel like.
No, I don't know the answer. Okay. And I just I think I want the prairie dogs one to be true. I'm going to pick prairie dogs because I want it to be true, but I don't know.
I think I'm going to go with the macaques. I think I gotta. That's just what my gut says.
Well, Deboki has written in the document on prairie dogs, this was based solely on me wanting to imagine a prairie dog with knitting needles. So
no! You got me again, Deboki. Congratulations.
Now, as humans get older, we tend to be more selective about our social relationships. Scientists wanted to understand whether this behavior was just like a human thing. And so they started to look at macaques and found that as female rhesus macaques get older, the size of their social networks went down and the proportion of their social networks that consisted of their family members went up. And they were able to determine that this effect wasn't due to them getting shunned or to the deaths of partners or other macaques around them that may have been their friends. It seems to be the result of choices made by the macaques. And there are some potential advantages to this. They might be less likely to get injured or risk illness by hanging out with a bunch of others. But researchers note that there could be other explanations. It could be a thing that older macaques are just less likely to participate in things that require a lot of energy. Or on the opposite end, their experience could make them better at just being on their own. They don't need that social support as much. So that is the true fact, which means that Sam is the winner of this Weasons? This season's Fact Off. This is why I can never do this professionally, right? Not Fact Off, but quiz portion. Everybody knows what I mean. But the bat fact actually is based on some truth. So bats live a really long time for their size. The Brandt's bat can live up to 41 years.
Holy cow.
And they think that sleep actually helps with this because it seems like they have studied epigenetic markers on bat DNA and found that hibernation puts a pause on aging during their dormant state, and that helps extend their lifespan. And that also goes for some non-bat species. Looks like Turkish hamsters also benefit in the aging department from their hibernations.
Wow.
So it's happening, you guys. We got life extensions right around the corner. All we need is to figure out how to do torpor like bats and hamsters do. And they're not that different from us.
The world economy would just be really fucked if we did torpor, though. That wouldn't work with capitalism.
We'd roll it. Everybody do 3 months and then, yeah. That'd be fun waking up being like, what happened? 3 months. Whoa.
You'd have to really mow the shit out of your lawn.
You got to alternate. That's why you got to plan it out. You have a lawn mowing schedule with all your neighbors of okay, I'm going in torpor.
Yeah.
See,
well, no, it becomes a VRBO. You don't need your house. You just
where do you go?
You go to the basement, you get in your torpor chamber, and then you Airbnb your house.
You have
Everybody
people
knows
around.
you're down there.
Your torpor chamber. That's a great.
Torpor chamber is not a good vibe. Don't use that, though.
No, too close to torture chamber, I think,
Yeah,
and like
exactly.
dungeonous
Yeah.
vibes.
I definitely would have my torpor chamber in the basement, for sure. Or maybe even below the basement, like just get somebody to dig out a little...
A dungeon?
Like a grave, kind of.
Yeah.
Yeah, like a long, skinny chest freezer.
We could put a lot of those all together, maybe, and then we could hang out as friends. And they already made that building. It's a mortuary.
If Hank was a vampire, he would absolutely sleep in a chest freezer. I could picture that perfectly.
Some dirt.
It's just cozy.
It's practical. Yeah. It's cheaper.
It was on sale at Costco.
Yeah, it came with the house.
That's a good idea.
All right, now we're going to take a little break, and then we will be back for the fact off. All right, welcome back, everybody. It's time for the fact off. Our panelists have brought science facts to present to me in an attempt to blow my mind. After they have presented their facts, I will judge them and I will award Hank Bucks to any way I see fit. It doesn't matter. Who knows what comes next? But to decide who goes first, I have a trivia question. People commonly translate dog years into human years by saying that 1 dog year is equivalent to 7 human years. Now, this is probably just based on the fact that the average human lifespan is around 70 years, and the average dog lifespan is around 10 years, meaning that it's not really a useful formula, but I guess it's better than nothing. However, a group of geneticists studying DNA methylation have come up with an intriguing alternative. As mammals age, our DNA accumulates methyl groups that stick to it, forming a way for scientists to track aging through what they call the epigenetic clock. These scientists decided to compare the epigenetic clocks of dogs and humans because we live in similar environments, and both of those things receive a lot of medical care. Based on their results, a dog that is 2 years old is equivalent to a human in what years?
21. It's party time.
That's exactly what I was going to say. I think
no.
they get to that age and then they freeze there for a long time and then they turn 80 instantly and die. That's my interpretation of what a dog does. I think a dog that is 2 years old is 25.
Well, Sam, aren't you feeling smarty pants today? Because the answer is 42.1.
Holy moly.
What the hell?
You get old quick as a dog, and then you just stay there, I guess. What the heck's going on? So the specific formula here is human age is equal to 16 times the natural log of the dog age plus 31.
The classic, the easy, quick mental math.
Yeah.
I saw LN and I was like, I couldn't even remember what that was for a second. Okay.
The lin of the dog age.
Yeah, so they studied 104 Labrador retrievers between the ages of 4 weeks and 16 years and compared the methylation profiles to that of humans between 1 and 103 years old. And they found that while the epigenetic clocks of a puppy and a baby lined up pretty well for a bit, once dogs get past early puppyhood, they mature much faster. And after early puppyhood, the dog epigenetic clock sped up for about a year until they reached sexual maturity, and then it started to slow back down again to match more up with a human's clock. I don't buy it. 2-year-old dog is not 41 in human years. All right. So that means that Sam gets to decide who goes first.
I will go first. For as long as humans have existed, we've been getting older. And for as long as we've been getting older, we've been trying to figure out how to stop getting older and maybe even get younger. Emperors, alchemists, and explorers of the ancient world hunted for elixirs or fountains of youth. At some point, we started to figure out more science stuff and stopped looking for magical solutions to our problem. Instead, we looked for usually equally as unlikely scientific solutions to our problems. And that brings us to Charles Edward Brown-Séquard, a French physiologist in the late 1800s. Brown-Séquard studied the nervous system, and from what I can tell, he made some important observations regarding the spine's relationship with the nervous system, how the nervous system regulates blood flow, and that blood seemed to contain chemicals that caused changes in the body. But he was also a fucking weirdo. He was notorious for operating on unanesthetized animals, the screams of which echoed through the various college buildings he worked in during his career. A fellow professor has accounts of Brown-Séquard at dinner parties trying to regurgitate and re-chew his food like cud. And the same professor who wrote that also found...
Y'all have never done that?
Not at a dinner party, just in the privacy of my own home. And then the same guy who wrote about the dinner party also has a story about Brown-Séquard. He found him in his lab covered in varnish and suffocating. And then the professor had to help him sandpaper off his breathing holes so that he wouldn't die. I don't think he knows why he was covered in varnish, but that happens. So this combination of half pretty smart scientist, half extremely weird, freaky old man made Brown-Séquard the perfect type of guy to think of a really messed up way to reverse aging. So from his animal experiments and observations of humans, he concluded correctly that people got old because the various systems of their bodies were breaking down. But he also concluded that old people were so tired because they had used up all the juice in their spermatic glands and they had lost their pep. And he also figured that the spermatic glands must be in the balls. So when he was 72, he was sick of being old and tired all the time. So he used his scientific expertise.
I've heard of this. I know where this is going.
To come up with his own anti-aging regimen. 1 part testicle blood, 1 part semen, and 1 part juice extracted from crushed dog and guinea pig testicles injected subcutaneously into his own body. So after 1 day of these injections, he reported feeling several years younger, able to climb stairs better, and even his urine stream was stronger. When he skipped his injections...
That's the classic definition of anti-aging. How hard's your pee push?
Exactly.
Yeah.
When he skipped his injections, he said his frailty returned, and he was so happy with the results of his own experiments that he did experiments on some other human test subjects and reported the same finding in them. He ultimately claimed that this routine made him feel 30 years younger, but he died 5 years after he made that claim, either at the ripe old age of 75 or the much too young age of 45, depending on how you look at it. So from a modern lens, it's unlikely that these subcutaneous injections actually did anything but provide a placebo effect because testicles don't store hormones. But I mean, like if dog balls reversed aging, I think the world would be a much different place than it is. His research and the research that other people did based on his research is said to have helped in the discovery of hormones and their function. And he's apparently regarded by some as inspiring the whole field of endocrinology. So he wasn't just smushing up dog balls.
Well, yeah, but he was also smushing up dog balls.
He did a lot of that. Yeah.
So it was crushed up dog balls injected under the skin. What else did he do?
So he mixed together testicle blood, semen. It doesn't say actually where he got those 2 things from.
From whom?
Yeah. I don't know.
Okay.
Maybe his own.
The youth. No, he can't put more old stuff back in.
He's got old balls. You're right.
He's got old balls. Absolutely not. He's got to find someone whose pee stream he admires and then be like, "Sir, can I please have
he's like sitting in the stall listening for pee streams.
Ooh,
be
strong stream.
Halt, you there. I need your testicle blood."
But his paper will be in the show notes, and it's a wacky old paper where he's just like,
all about it.
I was so tired and now I'm running up the stairs. Now I'm peeing really hard. It's great.
Yeah. No, that's how I feel when I have a Dr. Pepper. So take that.
No, they got a lot of crushed up dog balls in Dr. Pepper. So that explains
That's the main flavoring. People don't talk about it. It's vanilla, prunes, and crushed up dog balls. The 3 main flavors. Sari, what do you have for us?
In the spirit of things, also balls. So as we've been talking about,
this episode of SciShow Tangent
is actually
supposed to be about
balls.
aging. Actually about balls.
It's like some balls bookended by aging. So one way scientists have defined exactly what aging is biologically throughout history is to focus on sex, baby. In other words, an organism is born, it reaches sexual maturity and can reproduce, and then there's a point where it can no longer do that successfully, and it's on its way to death. It has no more fucks to give, quite literally.
Oh, Sari.
Thank you. And modern day researchers have started looking at much more specific questions like, is aged sperm worse at doing the do? Specifically, they're usually interested in questions of motility, or how well the sperm can move around and eventually mesh with an egg during fertilization. One way to answer this question is to look at pre-meiotic sperm senescence, which is a jargony way of saying how old are the cells that are making the sperm and what effect does that have? And in general, we found in mammals and other vertebrates that sperm made from older organisms has more DNA damage and has worse motility. But another way to answer this question is to look at post-meiotic sperm senescence, which is a fancy way of saying, how do sperm cells age after they've been made and are just hanging around? For decades, as far as I can tell, our main way of studying this was to make mice or rats or humans or whatever ejaculate and then see what's going on with the sperm as time passes. From these kinds of experiments, we learned that reactive oxygen species damage sperm in many ways, including motility, and there might be protective chemicals in the seminal fluid or other stuff. But those are all artificial lab conditions. So in 2008, a group of Hungarian researchers wanted to study how sperm ages post-meiotically in the wild, as it's meant to be. So they went out and caught 100 male common toads in the mountains, and then they released 52 of them because they had their pick of sizes and wanted a good range of them.
Okay, great. So 52 toads didn't have the time of their lives.
They did not go on this scientific adventure. And they chose toads for this particular experiment because they all stop hibernating and start making sperm at the beginning of their mating season. So their sperm was all around the same age, like a great equalizer. They divided their male toads into 3 groups of 16. One group that they put in the cold and dark to make them rehibernate, one group that they kept completely isolated from females, and one group that they let mate with new females as many times as they wanted, which ranged from 1 to 4 times. At the end of 300 hours, which is about the same time as these toads' natural mating peak, they did lots of sperm science. And to skip past the testicle smashing to the results, there was frog testicle smashing involved. They found that the rehibernated males had the most sperm motility. So after their body made sperm, shutting everything down again helped prevent sperm aging and kept the cells really fresh. So something about hibernation slows the biological process of aging, even in specific cell populations. And what was also kind of surprising was that of the non-hibernating groups, the toads that mated had better sperm motility than the ones that didn't. So something about females being around or getting to blow their load helped with the overall quality of aging sperm. They said the implication of this is that more frequent ejaculation may help remove the old stuff or reduce age-related damage, but in general, it opens up a lot more questions than it provides answers. And we obviously can't extrapolate these conclusions directly to humans, but they may help add to other knowledge related to sperm banks or other forms of reproductive science and aging gametes, because there's just so much to learn about aging in different types of cells. You can't treat any of them the same.
So I thought all 52 frogs were going to have, or 48 frogs were going to have the time of their lives, but only a third of them did.
Yeah. Well, a third of them got to take a nap, which is pretty sweet. A third of them had the time of their lives.
Sari's like, now what's better? I've heard about sex, but have you tried a little nap?
A little cozy nap.
A big old long nap where you get to, and it turns out it's great for you. It's great for your whole situation.
Did they all get their balls smashed though?
I think a select number from each population got their balls smashed.
Okay.
And
then the last few frogs were walking out the door and the scientists closed it and said, not you. Excuse me.
Not you.
We have a little bit more business to attend to.
So I think here what we have is maybe a little bit more useful information in the near term. That like a little bit of fresher science with Sari's fact, but ultimately we do have a man who maybe created endocrinology and also injected crushed up dog balls under his skin. So Sam's going to come out the winner on this one, which means Sam is also the winner of this episode of SciShow Tangents. But is he the winner of this season of SciShow Tangents? You're going to find out soon, but not quite yet. Because first, we have to ask the Science Couch, where we have a listener question for our couch of finely honed scientific minds.
Laughing Mom Fish on Discord asks, I've read several articles about the recently announced gene therapy that can reverse aging, and I have many questions. But just now, I was wondering, if you did this treatment on someone and, quote, turned back the clock on their body, how many times could you do that?
I have heard of the bare minimum about this, and I'm kind of bad about longevity stuff because it's so hard not to see it in the historical context of every single generation of rich guys has been obsessed with this since the beginning of time. Yeah. And so it's like, and they've always been wrong. Ponce de Leon was not going to find the fountain of youth because it didn't exist. But look, it'd be great to deal with aging in a lot of ways. It'd be great, be very good for human health. It'd be very good for health outcomes to be in more control over its senescence. But I don't keep up on it.
I don't keep up on it either. So I don't think it's bad of you. I think I was trying to search this, and the problem is I have already a level of like bullshit filter on the way that I search things. And so I did not see the most clickbaity articles about it. But the big thing is on January 12th this year, 2023, in Cell, the magazine, the
journal.
The digest, the journal. I couldn't remember the word for it, the comic book.
The periodical.
The periodical Cell. There was a study published about how epigenetics and how epigenetic information can both drive aging and reverse it. So this study, specifically what they did, and what I think is not making the headlines as boldly, is that they broke the mice before they fixed them. Okay. So they took normal mice and then used a technique that they called ICE, which is inducible changes to the epigenome. And they just made a bunch of cuts in DNA, messed up the DNA in these mice, and found that the epigenetic information on the DNA, the way that it was methylated, the way that it was bound up and packaged, started getting weird when they made enough cuts to it. So like this damage led to weird packaging.
Right. So they were inducing epigenetic weirdness by doing a bunch of cuts on the DNA.
Yeah, by messing with the DNA. And then these mice that had a bunch of weirdness introduced to their epigenetics displayed signs of aging. They ran slower on treadmills, their grip strength weakened, their hair changed texture, and like cells started losing their identity a little bit. Like the skin was
pee stream. Was their pee stream real strong? Or
probably
like
weak. Organs failed, so I'm guessing the pee stream was weak. I'm guessing they couldn't climb stairs. All the problems that this man, and instead of injecting dog balls into them, they injected a combination of genes that are generally known to be active in stem cells. And stem cells are these cells that are like in your bone marrow and can differentiate into a lot of different types. They're generally like, they keep generating new cells that are healthy, as opposed to being cells that are frozen in time and get old or die. So they injected this gene cocktail into these broken mice. And then after that, the problems, the epigenetic weirdness that they introduced, seemed to reverse itself. Whatever this gene therapy did helped reboot their cells in some way. The scientists compare it to rebooting a malfunctioning computer, where it gave the template again for healthy cells and helped restore organ function and restore some tissue function and restore some mobility. Their pee streams were stronger, probably. And that is the reversal of aging. So they like induced symptoms of aging and then reversed it. And they don't know why or how it happened. They just kind of were like messing around in mice.
I mean, that seems still like a pretty big deal.
Yeah, it's not nothing. And so there's something to it, and that's cool. Like there's this idea that we can improve quality of life, or like health healthfulness. Potentially, if we know which genes to help amplify to like help our systems as they're breaking down, keep doing good. But it's not this like the way this question, like turning back the clock. It's not a Benjamin Button situation. It's not a injecting dog balls into you situation. It's not going to be like a magic fix unless you were broken in the way that these researchers broke you. We are not anywhere near that yet. It'll be like a little boost of vim and vigor, just like I don't know, having a good day.
Faster. My pee stream's a little bit better. This is great. What it sounds like to me, honestly, is that I need to pay more attention to this stuff because, like, at this point, it seems like the research is going to start to matter probably sometime during my life.
Then we can have a forever Hank.
Well, you're going to get that anyway. He's going to be made out of artificial intelligence. It's going to be great. Which hairstyle do you want? Just pick.
And the goatee
Hank,
too?
Definitely.
Can we pick the goatee?
That's it. Immediately. Because it's the correct choice.
If you want to ask the Science Couch your questions, you can follow us on Twitter at SciShow Tangents, where we'll tweet out topics for upcoming episodes. Or you could join the SciShow Tangents Patreon and ask us on our Discord. Thank you to Ike on Discord and at WitchHouseKey and everybody else who asked us your questions for this episode. And now, the results of this season of Tangents. The panelist who won the most first half games. That was Sam. As of this episode, Sari came in with 10. Sam had 11. You somehow tied 14 times.
That's
so you're
crazy.
Both either bad or good at this. That's great. That's huge. The panelist who got the most trivia answers right. That was Sam with 20 wins to Sari's 15.
I'm on a
Trivia
roll, baby.
king.
I'm going to sweep
That's
the rest
right.
of them. You'll see.
The most frequent winner of Fact Off was Sari with 18 to Sam's 13. You also tied 4 times somehow. It's just hard to make up my mind sometimes. We also posted a poll on Twitter so that our audience can decide on their favorite Fact Offs. And the winner of the most Twitter polls, the Audience Choice Award, that's going to go to Sari with 14 wins. But we haven't polled for this episode yet. So it might end up tied because Sam has 13 and you tied one time. Even on the Audience Choice, you tied once, which is amazing.
That's sweet. Thank you. They were both equally
wild.
loved. I'm just loved one little tiny bit less.
And the panelist with the most overall episode wins was Sari with 18 versus Sam's 16 with one tie. So you were very, very close, Sam.
I did not do that this time.
Season.
You guys are always saying, you're so stupid, Sam. And I'm always like, no. But I'm doing good.
Sam, that's the inside of your brain that's doing that.
Oh, okay. Okay.
So that's the end of season 4 of SciShow Tangents. Congratulations to Sari on her win. Next week, we'll have a rerun. Then on March 28th, we'll be back with the beginning of season 5. But we are changing things up. We're going to change our upload schedule from weekly to every other week. There's a bunch of reasons for this. Ideally, we'd like for a season 5 to have some bigger and better facts off, some wild new games, some more guests. We want to do a little bit more of that. So we want to devote more time to that. We also are just adjusting our stuff generally because while our audience has continued to grow, and we love that, and that's because you've been telling people about us, it's because of other reasons. I don't know. It continues to
tweeting
grow, which is
about
fantastic.
us, which I guess is telling about us.
You've been tweeting about it. You've been continuing to listen and watch. But the ad people have not been buying more ads. So there's that problem. So we're moving to every other week. We think it'll help make the show a little bit more ambitious, more sustainable, hopefully more fun. And if you need more tangents in your life, you can consider supporting us on Patreon. There you'll get some monthly bonus episodes. You'll get access to our Discord. You can talk to us, ask us questions, talk to other people who love the show. And finally, our normal outro. If you like the show and you want to help us out, it's very easy to do that. You can go to patreon.com/SciShowTangents. You can get things like our newsletter and our bonus episodes. Thanks to patrons John Pollock and Les Aker especially. Second, you can leave us a review wherever you listen. That's super helpful and it helps us know what you like about the show. And finally, if you want to show your love for SciShow Tangents, just tell people
about us.
Thank you for joining us. I've been Hank Green.
I've been Sari Riley.
And I've been Sam Schultz.
SciShow Tangents is created by all of us and produced by the fantastic Sam Schultz. Our wonderful associate producer is Faith Schmidt. Our editor is the one and only Seth Glicksman. Our story editor is Alex Billow. Our social media organizer is Julia Buzz Bazzaio. Our editorial assistant is Deboki Chakravarti. Our sound design is by Joseph Tuna-Medish. Our executive producers are Caitlin Hoffmeister and me, Hank Green. And we couldn't make any of this, of course, without our patrons on Patreon. Thank you, and remember, the mind is not a vessel to be filled, but a fire to be lighted.
But one more thing. For a while, we didn't understand why C. elegans worms seemed to self-destruct in old age after they couldn't reproduce anymore. Towards the end of its lifespan, one of these worms will basically dissolve its internal organs into a goopy protein liquid and poop out more than its own body weight in unfertilized eggs. For a while, we assumed that this was some sort of age-related disease or senescence causing problems. But a 2021 study concluded that this process is actually more like a primitive kind of lactation, a way for C. elegans to use up every last ounce of energy to make worm milk and eggs to feed any offspring around. So we may be able to study these worms more to understand what genetic triggers cause their cells to age all at once after reproduction, or what holds off this wormy milk process during the rest of their life.
I mean, I've heard some things in my time.
Worm milk.
But whole body
Worm,
turned to
milk
milk.
to try.
Worm lactation cannibalism isn't one of them. That's new. It's wild that we would have found out about this so late in the game.
Yeah.
Yeah, we just didn't pay attention. We were like, they're old and feeble. Their pee stream's weak, and they're just popping out all these eggs.
Look at this loser disintegrating. That's what we said. And left
Yeah.
it at
Yeah. And then do they just die?
Yeah, I think they die after it.
My God, this is what I'm saying. The genes don't want to keep us alive. They want to keep themselves alive, and they'll make you shoot out your body weight in eggs and leave the rest of you an empty husk to just die so that you can keep the genes alive. It's a great story, though. Sarah, we need to write this book. I don't know what it is, but
Oh, it's a new book. Is this a new book?
yeah, this one's about
Milk?
milk. It's called milk.
It's a great title for a book.